Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, just sort of a casual exploration video, I want to take a look at this DTC 1181 card. It's some type of a card that adds, well, looks like a ROM and RAM to a computer, IBM PC that is, and I want to see what this thing is all about. DTC manufactured all sorts of PC peripherals back in, well, I think it was really in the 80s and 90s. They made motherboards, they made expansion cards, they even made their own BIOS. Well, at least they branded their own BIOS on their motherboards. And I'm talking like XT class stuff. It's apparent by looking at this card that when you add this to an ISA slot of an IBM PC, it's obviously designed to add an expansion ROM, but oddly, it also has some SRAM. And I'd have to look up this part number to see exactly how much SRAM this is, but it's probably 2K of SRAM. The part numbers of these chips were varied. They kind of went all over the place. And looks like the date code on this is 1994. So this is kind of a late card. We also have 1994 24th week on this 74 LS245, so that's a bus transceiver. And then we have a PAL chip down here, which is certainly going to be used for chip select functionality. So in order for you to add a ROM into an IBM PC, you have to have it be able to be selectable when you hit certain I/O addresses, or sorry, you hit certain memory locations. So this will be mapped into the memory space of the IBM PC. So you need something to look at the address lines across the ISA bus and then turn on the chip at the appropriate time and potentially have it be selectable using some switches or jumpers, as in the case of this. But we also have this SRAM, so it makes sense that this is being mapped into the memory space as well using this PAL chip. The PAL chip is replacing a bunch of TTL logic, so it's not going to be obvious to us how it's mapping these two chips in. But I think a little bit of reverse engineering on this card, plus we need to do some Googling to see if we can find information on this card. Maybe there's already some pre-existing information out there. Plus it'll be really interesting to dump this ROM and see what exactly this is doing. I'm thinking from 1994, it makes sense that this extra ROM might be for adding hard drive functionality. So that'll be just like a card like this, which is basically very similar, where this just adds XT IDE into the address space of an IBM PC. Now this card, which is from Monotech, I actually had these PCBs built up, and then I made this card myself. It just requires a couple components using a 74LS688, which is underneath that socket for the chip there. We have some dip switches here, a couple jumpers, and this allows you to configure the ROM to be mapped into the memory space. And then you can select between 256 kilobits or 8 kilobit ROMs, 8 kilobits being 8K or 256 kilobits being 32K ROM. Now, when you have 32K ROMs, you can only map them into these spots with the dots, and that's because, of course, each of those locations is 8 kilobytes in size, so larger chip, you only have 4 spots you can map this into. I'm sure something similar is going on with this card, it's just this is going to be an old vintage version of the card. So at the minimum, what I could do with this card is add an XT IDE ROM to it. And whatever functionality this has, well, we could replace it with a much more useful XT IDE. The thing is, it's got SRAM too, which potentially you could use this for loading some stuff into high memory. And it even has the footprint for a larger chip, potentially one that can hold more than 2K. If this is a 2K chip, which again, we'll look up the part number, maybe we can go to an 8K chip, or we can even go to a 32K chip. And then you could potentially have 32K of high memory space that on an XT class system, you could load stuff into to add more or get more conventional memory support. Now, incidentally, with this card, you could do exactly the same thing. In fact, notice here it has a dip switch for writable, this one right there, switch 6. So normally with a ROM, you wouldn't have it to be writable. But if you're adding in an SRAM chip, one of these 32K SRAM chips, into this socket, then yes, you can add high memory with this Monotech card. So there's nothing revolutionary going on with this DTC card, especially because the Monotech card does pretty much everything this could possibly do. And you can build these yourself, and they're very easily attainable. But on the other hand, it's just sort of curious to see period correct things like this. And I just want to kind of explore what exactly this does and how these switches work on this. So first things first, I did a quick Google search on the RetroWeb, and I did find this card. This is the exact card. It looks, well, I guess it doesn't really look different. It has no SRAM installed on it, and it has an FCC logo underneath there, which might possibly be on this card anyways. And one other difference is the card on RetroWeb has a GAL chip, and this one has a PAL. GALs are just rewritable. PALs are one-time programmable. On the back side of the RetroWeb one, it says PCB Rev A, This one says the same thing. In fact, these markings look, yep, basically exactly the same. And this sticker here says 9798. And this one, if you can make it out, it says 1995. Warranty void if removed, 1995. And I guess it is February. If we look at this, it says ROM extensions provide Y2K and eIDE compatibility to older systems. Well, I'd be sort of skeptical if this older 1995 one does Y2K. Were people really thinking about Y2K compatibility back in 1995? Maybe, but that doesn't seem likely. And the dates on the chips on here are 1994. Now we do have some jumpers that have already been documented. Jumpers 6 and 5 have to do with the memory location of the ROM chip, the 16K ROM size. Now it's interesting that it's 16K. This is a 27C256, which, isn't that 32K? So the way we figure this out is you just take the 256 in the EEPROM and you divide it by 8 because it's in bits. And yeah, it's a 32K EEPROM. At least this one is. If it was a 27C128, it'd be a 16K EEPROM. Now, if we look at the picture, we cannot see the size of this. DCT 1181 Y2K 1.2. So we'll have to dump this ROM and see if what's on here is the same. It just has a sticker on it, obviously, so I can't tell. But we do not have the SRAM, while the one that I have in front of me does. Now, going back to these jumpers, we also have 4, 3, 2, and 1 not installed. That matches what we have on this card. And the rest are 1-2, which is exactly what we have on this card. Now, the other jumpers 5 and 6 are set for 2 and 3. So that means it should map into C8000. So we'll plug this into a computer and we need to see if that's the case. So this one on RetroWeb says usage drives over 528 megs, use drive type 1 or 2 for D drive, compatible with BIOSes such as AMI, Award, and Phoenix. Cross platform with Mr. BIOS is not compatible. If you format a drive using LBA on Mr. BIOS, it will not operate with this BIOS. Okay, so it is sort of like an XT IDE in a way, allowing you to break that 528 megabyte barrier, which pretty much existed on all BIOSes. I don't really know when that started changing, but certainly 286s, 386s, and potentially some really early 486s all had that barrier. So if you needed to use something larger, you did have to use a third-party BIOS. You do have to be careful with using these BIOSes, and the same goes for XT IDE, because theoretically, if you're using one of these for your hard drive routines to break that barrier, well, these are just 8-bit cards. That means that access to this BIOS is going to be very slow. And on a lot of these later motherboards, of course, the system BIOS was cached in the RAM, and the RAM being on a 386 or 46 was really fast. Maybe cached is the wrong name. It was shadowed. And that means that on initialization, the BIOS copies the ROM code from the system BIOS on its slow ROM chip on the motherboard, copies it into RAM, and then it runs all of like the operation of the computer from that copy that's in RAM. Well, RAM is really fast, especially on a newer computer, 32-bit data bus, low weight states and things like that. These ROMs are super slow. So if you use one of these cards on a fast computer, unless that computer has the ability to shadow this BIOS into the main memory and then execute from that, you're going to have a massive performance implication using really either of these on a pretty fast computer. And the machine I have sitting on the bench right here to do testing with is a Pentium. So it doesn't even really need these, but it certainly, I think it will still work on it. And the reason why I'm using this Pentium motherboard is I want to be able to boot off of the compact flash card, but of course its own internal BIOS doesn't require any modification to use this large card. It's a 2 gig card. But if I was running this on my 36SX, I would need XT IDE or potentially this BIOS to even get that card to boot. And the problem is if I'm using XT IDE, like this card, that means that this is mapped into the memory space as well, and I don't want to conflict with this, because I want to figure out exactly what's going on with this SRAM, and we want to see how much of this ROM is actually mapping into the memory space, and we want to see if what's on the RetroWeb is accurate or not. Here's the motherboard I'm going to be testing with. I think it's a Pentium 200 MMX. We have an ATI something or other PCI video card, a certain amount of RAM, and then I have my compact flash adapter. It's just on the internal IDE adapter. Incidentally, this used one of those Dallas clock chips that had failed, so this is using one of Necroware's replacement modules on here, and it's pretty darn awesome. I gotta say, I love these. What else is there to say about this? There's a power LED, I have a reset LED, we have a speaker that's fixed. This thing here is a serial port if I want to use a mouse or something like that. And yeah, let's turn this on. Oh, I got to get power connected to it. And then we can see if this computer works. Always got to test first, right? Just in case something is broken. And then we'll see if we can see what's on this chip here. We can actually dump the contents of this directly on this computer without even having to take this ROM off. And I'll show you how I do that in a second. So first we'll turn this on. So how much RAM is in this thing? Okay, I guess it's running at 166. 32 megs of RAM. And what we want to do on here is just turn, oh no, we want to leave the hard drive type set to auto. You know what's interesting here actually is I'm not even sure if I put this card in here at the same time, it might cause a problem and conflict with what's happening in the stock BIOS. Interesting. Well, I think we're going to reboot the computer anyways. Let's just make sure it boots up and then we'll pop this in and see what happens. If I need to plug this in while the computer's running, then I'll do that. And yeah, that's okay to do as long as you don't like short any of the pins. I've done that many times. Doesn't seem to really cause a problem. All right, so I use the program ROM Dump, and this was written by Jim Leonard, and I've used this a lot. Hence, you can see all sorts of stuff in here that has been dumped. Now, the way I usually use this is, what is the name of this computer? I don't know, let's just call it Pentium, and we make a directory for it, go in there, and then the program itself is called ROM Dumper. So I just run that from the previous directory, and it dumps all the ROMs that it can see. So all the F000 through FFFF, that's the system BIOS, and it does say it sees, oh, a ROM at C000, that's gonna be the VGA card BIOS. So if we take a look at what we see in here, we have 3 different ROM files, and I'm positive that this Rage XL ROM BIOS is what we're seeing there at C000. What I need to find is a DOS hex editor, but I don't think I have one on here right now. Oh, maybe I do actually. Let me see if I do. I can't quite remember if I do. I'm using HDIR hot directory just to format everything, just to make it a little bit easier to see. Isn't one called like XVI or something? No, I don't think I do have one on here. It'd be helpful for us to be able to hex edit these files that we dump just to kind of tell what they are. Okay, I did a quick search and I found a program called UHEX. This is a DOS hex editor that looks like it works on any 8088 or 8086 compatible CPU by Matheus Viste. I'm sure I'm saying your name wrong. And it looks like you can open files in read-only mode. I don't know if there's a size limit or whatnot. Let's try hex editing itself. Yeah, there we go. So this is the program itself. Well, it looks like it works. Cool. So let's take a look at that ROM, the one I think is the VGA card. And yes, there it is. ATI Rage, SDRAM, BIOS, part number, blah, 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 blah. Very typical, well, I mean, pretty much standard that EGA and VGA cards are always going to exist at that C000 space. So anytime you run ROM Dumper, it is going to dump that particular ROM. And yeah, that confirms what it is. Let's check out the other one, which I think is the system BIOS ROM. Boot from ATAPI CD-ROM. I think it's the other file we really have to look at. See, this does work. It's pretty quick too. You can zoom through the file here. Here's the other file, the one that starts at F800. I think usually at the very end we'll see the BIOS string, theoretically. There's the date, 1996. PC ISA, I don't know, somewhere in here. It's pretty much a standard location, I think. We'll actually see the BIOS string. Now, it's quite possible this BIOS, which is an award BIOS, is bigger than just 64 kilobytes. And that's because these systems have the ability to have extra ROM, because this is a Pentium, right? So it's a 32-bit system, so it's got ability to have bigger ROM. So there it is, award software, written over and over again. Yes, copyrighted. I don't think that you could take this file necessarily, those 2 files, the F files, and make a replacement ROM for this, because on these later systems, I think there's more going on in the ROM than just what you see exposed to real mode in DOS. On older systems like XTs and 286s, this totally works. You could just run ROM Dumper and get the ROMs without having to even take anything out of the system at all. So it's quite useful in that regard. But we know for sure that the only ROMs we're seeing right now are F000 and C000. So theoretically, anywhere we stick this should not conflict with anything. So let's start by popping in this card, the DTC card. Let's see exactly what that does, if anything. Luckily, none of the tantalum's shorted on it, so that's a start. It takes a long time for this computer to even do anything. Now we should see this card have a banner, theoretically. Oh, there it is. Oh, pause. So 1994 DTC Enhanced Drive Parameter Table, the EDPT10A, and the date is 11/23/94. Okay, well, it is detecting the 4 gig card, which has a physical size of 7785 cylinders, 16 heads, 63 sectors, and it's showing the BIOS setup, 973, but 128 heads. Drive D not installed in CMOS. Okay, so I don't know if this is going to keep the system from booting. Let's see what happens. It may. So yes, it is not booting. Oh, it booted. Okay, that's cool. So let's redump the ROMs. We can just delete these ROMs because we don't need these. We're going to get the extra one for this card, which should be at C800. So we're just going to get this by going ROM Dumper and let Jim Leonard's utility do its thing. So there it is, searching, and it found it at C800 hex, and it found a ROM signature, which I think is how this program from Jim actually figures out that it should dump the ROM. It looks like it dumped 14 kilobytes of ROM space. This chip that's on here, remember, it is 32K, but it could be they just used a larger chip. That's not really needed. Oops. So we can hex edit that now, C800. There it is, DTC. So this is all that's needed, as far as I'm aware, to actually, make a new EEPROM. So if you wanted to use this ROM on, say this little Monotech card, you could do that. This ROM will work in here. Int 13H, function 8, CMOS type, not supported. Obviously, reverse assembly or disassembly of this will be required to figure out if it has any Y2K capabilities. I somehow doubt it. This is certainly just large IDE hard drives. What we're looking at here is that table that prints out when the system boots. Unable to locate host adapter, unable to obtain drive parameters from master drive. So this really is designed to work with IDE drives. Please check the jumpers connected to the IDE drive. More stuff about messages, and looks like that's it. That's the end of the BIOS. So even though more of this dumped, the reason why Jim's utility knew how much of the ROM to dump is because the checksum byte is right there at the end, 96. It's kind of a, I don't know, they do a sum and they add everything up. And when you add that byte into it, it needs to total to 0. Everything after this, like starting at 38, well, which isn't in the file, but I bet you if we look at debug, it probably comes back as like FF or something like that. So Jim is checking for that checksum byte, and it will dump everything up until that point. I think we're gonna have to use debug now to start poking around a little bit. So this is that DTC ROM, the one that was dumped by Jim Leonard's dumper program. So if we kind of look through this, in fact, oops, I just accidentally wrote something into memory. Hope that doesn't cause it to crash. So this is near the end of the ROM. If we keep looking here, we should run into that checksum byte in a moment. Can't remember where it is exactly. CB, there it is, right there. So see how it says CB0007F0, and then there's a 96, and now we just have, well, 55AA almost looks like it's another ROM. Now, is what we're looking at here actually the SRAM by chance? We should probably write into this and see if we can write to this. Yeah, I bet you it is, because look how it says InnoDisk there. That's the name of the compact flash card. Why is that there in memory? If we take a look at somewhere else in memory where there's nothing mapped into it, let's see how that looks on this system. So we can just do D000. Okay, so you just see it as all zeros. That's what you get on this particular motherboard when there's nothing there. This varies by motherboard. You might see Fs. It just depends on how the data bus floats. You might see kind of like random gibberish. You might see AA, BB, something like all over the place like that. But I think I can never remember my addressing on 8088s. It's kind of complicated, but there it is right there. So CB80:8 is the same thing as CB800:0800. It's, if you're not familiar with how the addressing works on 8088s, you gotta go read up about it, because even I barely understand it, but that's essentially the same thing. Let's try writing to this memory space and see if that is indeed that SRAM. Okay, so that command I just did there, I think that should have filled AB for the first 10 bytes. We can tell that by going back and dumping the memory. Yeah, there it is. Okay, it wasn't 10 bytes. Obviously, I filled AB bytes with 10. So that is writable memory. If you tried to write to something else, let's do that same command again, but we'll do it to D00:0, and we'll do that same AB. So I'm gonna write 10 AB times, AB hex, to something that doesn't exist. Now when we take a look at D00, we're not gonna see anything. Well, I don't think we should. Oh, okay. Why are we seeing something? This might be the effect of the fact that all of this memory up at the top there is shadowed. Yes, yes, that's exactly what's happening here. All of that memory is shadowed. What does that mean exactly? You know how on a 386 and higher, you can use like DOS equals high and stuff like that. What's happening with these systems, even though I didn't boot the system with high mem or eMem386, the BIOS is doing this, I think, and the chipset is doing this, is the top 384K of memory is actually, it exists in the RAM, the physical RAM itself, but it also exists in the ROMs on these cards. And there are options in the BIOS to shadow or copy the routines from the card into RAM. But the fact that even where there's no card at all existing on the system, like there's no, card at D0000, you can still write to this RAM. What I need to do is go grab a machine that doesn't do this, like a 286, and we'll see that this effect is quite different. I went and grabbed my 286 board. This is the SCAT 286 that I did a big video series on, where I overclocked this thing and I replaced these SIP sockets with SIM sockets. And let's, well, to use this, of course, it doesn't have IDE adapter, so I'm going to use this card that has XT IDE on it, and it's at C000, so I'm going to have to remap that if we want to potentially use this DTC card at the same time. Or I could just remap the DTC card, I suppose. So I'm going to pop the same little card into there, make sure everything is ready to go. Video is not plugged in. I just grabbed a random 8-bit ISA video card, but that's good enough. And this system, does this have a battery on it? Yes, it does have a battery. How much RAM is on here? I think it has 8 megs of RAM, potentially. It's got a bunch of sockets on it. Yeah, 8 megs. So moving system ROM to shadow RAM. This is what I was talking about with the shadow RAM. Diskette problem. Yeah, well, there's no floppy drive plugged in. Correct problem. This BIOS is hilarious. Control S, Control Alt S. There we go. Okay, well, sorry, everything's a bit blown out. That's the video card we're using here. I don't have any floppy drives configured, so why was it complaining about that? The ROM might not be mapping into the memory space, so that it's not seeing the compact flash card. In fact, I think that's what's going on. This has XT IDE on it, but we should see the banner pop up. Oh, there it is. Okay, InnoDisk. Oh, that wasn't happening before. I wonder why. There we go, system's booting. Now let's take a look at debug. So C800, which is where this card has its BIOS, there's the XT IDE BIOS right there. And let's take a look at D0. It is all Fs. This is what I was thinking before. So let's try filling at this location where I don't think we should be able to write to memory at all. I'm going to use that same command. It's AB times, and it's going to write 10. And we're going to dump this again. And there we go. It made no change. So now the question is, with this card, if we pop this in, and I do have to disable the ROM on this XT IDE card that I have in here, will that memory space right above the ROM be writable in that SRAM chip? So J11, BIOS enable or disable? J11, here it is, disable BIOS. Okay, so let's disable that. Just want to make sure, I'll power the system up first, make sure that is disabled. We don't want to create a bus conflict between this card and that card. Okay, there we go. It didn't show anything. So I think that's working now. So I'm going to plug in the DTC card here. And let's see if this now pops up with the BIOS, and then we can try to see how that SRAM is working. I'm also theorizing that some of those jumpers that are on there maybe potentially disable the SRAM chip. Maybe, maybe not. We'll have to take a look at like how the traces are routed on there. What's going on? We should see it, right? Oh, there it is. And it says unable to locate host adapter. Well, that's weird, isn't it? I wonder if I'm having like a signal integrity issue with these slots. I'm going to try a closer slot. This host adapter just uses a normal IDE, port, 1F0 or whatever it is. It's an IO port. So there's no reason why disabling the BIOS on here should have disabled the IDE port. It should still work. If it's bad, I have another IDE card I can grab. Now, incidentally, I don't know for sure, the instructions on RetroWeb, yeah, it still says it, can't find it. The instructions on RetroWeb were a little vague as to like whether you should set a hard drive type to use this DTC adapter. So I guess I should try. Oh, give me a break. There we go. So let's set a hard drive in here. I don't know, we'll just use type 2. Let's see if that makes a difference. It's quite possible that the DTC BIOS actually looks to see if you have something configured in your BIOS. XTIDE doesn't. It just talks directly to your drive interface controller to see if you have something there. So obviously I have the wrong type set, but it's enough to not fail the hard drive check. Oh, look at that. That was it. And it boots now. Very interesting. Okay, so that's a little bit of an interesting tidbit. Now, performance is going to suck because I don't think I have the shadowing configured in the BIOS on this motherboard. By the way, I'm curious with this computer, how fast is this machine? The video speed is going to be slow. Okay, it's running at 14 megahertz, but the effective speed's 21. There is a turbo jumper on here. Okay, that makes it slower. I guess I couldn't really overclock this system anymore. It has a 20 megahertz 286 chip in here, but I suppose the chipset that's on here, Chips and Technology chipset, has a -12 after it, so I'm assuming it's rated for 12 megahertz, and even as it is, it's being overclocked. And yeah, the crystal that's in here is 28.32 megahertz, so it takes this, divides it by 2. Anyways, it's a very fast chipset. If I could get this to run at a higher speed, this machine would be blazing, just because you could see that even with the clock speed at like 14 megahertz, it was running effectively at 21 megahertz. So that kind of tells us if we could run effectively at like 16 megahertz or even 20 megahertz, this machine would be more like 30 megahertz equivalent to an original 5170. Either way, we've got off topic here, right? If we take a look at the C800, that's the BIOS, the one on this card. Now let's take a look at, I already forgot what it was. I think it was C80. Yep, that was it. So I recognized the 55AA at the beginning. And in there is the name of the drive. Let's try filling, I'm going to do it down here at the bottom, because we're literally booting this system using this ROM. I don't want to corrupt this memory. I don't know if this RAM is just used for, well, I don't know what this is used for, but it's got to be RAM. It's got to be the RAM we're looking at, because there's no way InnoDisk, which is the name of the compact flash card, would be in the ROM, right? That's not possible. And we already know with this motherboard, if I write to memory space that's not occupied by a card, it doesn't do anything. We just see the FFs. And we're seeing all these 00s here. So I can do that fill command. So CB80:0130, we're going to fill it, I think AB10 was the command I was using. Well, the fill command doesn't work. I think I'm using it incorrectly because I'm specifying after the colon there, I have more digits than should be there. So let's try to figure out how this should work. So CB8, I think it should be 93. That should be all zeros. Okay, that doesn't look like it's used. So now I should be able to write to this, or fill it, that is, AB10. Okay, that worked. 93, 0. Yeah. So that is definitely the SRAM that's on this card. And we can tell that this ROM is using it. Now the problem is though, is of course, that means that the PAL chip that's on there is only mapping the first 14K of the ROM. No matter how big the ROM is, only 14K of it gets mapped in. And then that SRAM exists. I'm trying to see how big the SRAM is. When we get to the end of the SRAM, there are those 10s I wrote to it, still sitting in there. It should just start showing FF. Oh, there's more stuff in here. InnoDisk, okay, so it used up a bit more space down below. I think this is a 2K chip. I forgot to look up the part number. Oh, there we go. That's the end of it right there. Okay, a little bit of calculations. This is what we're looking at here. So the ROM itself exists between C800 and, well, it's 37FF long. That is 14 kilobytes in size. So it's 0 to 37FF. Now, if we're going to look at it in debug and we want to have the :0, then basically it's CB7F. That's how you would start looking at it, but really, that's the ROM. As for the SRAM, it goes from CB80 to CB80:7FF, which is 7FF in size, and that equals 2K. And this one is 14K. And the reason why that's important, because it looks like the entire address space of this card is probably 16 kilobytes total. So it doesn't actually use anything else beyond that. And probably what I need to do is just look to see at the top of the SRAM if it just wraps around and maybe list the ROM a second time, but I doubt it's doing that. Now, according to RetroWeb, we have different jumper configurations, and I'm just going to write that into here. I have a feeling the entire address space moves. So the SRAM and the ROM itself move to whichever address space you have selected based on those two jumpers. So that was the top of the ROM right there. And let's look at the top of the SRAM. So to get to the SRAM, it is 3B80:0. That's the SRAM. And this should go all the way up to 7FF. And that is basically the 2K of SRAM. So when we get to the top of it, it should just start showing FF because we've gone into address space that's not mapped to any card. Yes, there it is. We get a 4C at the end. It's interesting because you notice at the beginning, I think I had like a 55AA. That is very much acting like it's a ROM. And that last 4C feels like it's a checksum. So now that we're in the Fs, and we know we've gone from C800:0 all the way up 16 kilobytes to look at the actual same Fs we're looking at there, what we would be looking at is CC00:. So those are the same Fs. So what I want to do is I want to use this little right angle adapter so we can manipulate the jumpers that are on the DTC card while the system is running. And we should be able to potentially see changes in its mapping with changing those jumpers. Plus what I'll be able to do is manipulate these jumpers, these other jumpers, so we can see exactly what they do when the system is up and running. In fact, let's take a closer look at the various traces that are going to these. So we can be pretty much sure this top row is going to be connected, well, at least those pins. Interesting how that doesn't seem to be connected. These pins here are going to be connected to probably 5 volts, or let's check out that cap. Yeah, that's going to be 5 volts because this is on the positive side, it's electrolytic. So that top big thick trace that goes to C3 on the top pin. Oh no, that is, yeah, 5 volts right here, top pin. And then the other pin is going to be the negative rail, which almost certainly is what these are connected to. Now the funny thing is this first jumper, which isn't even installed, that doesn't appear to be hooked up to ground or 5 volts. Let's just confirm that with the multimeter. Okay, I made a mistake about the polarity of these two capacitors. So this is the positive side towards the edge of the board, and that's the positive side of the tantalum, which almost certainly is connected to probably this right here. Yep, it is. And then this is going to be the negative side. So all these pins are going to be on ground, but that pin's not, and that pin is not. Oh, but this pin is. Okay, so that's hooked up to ground. So when it comes to this end jumper that's not installed, it looks like when you have nothing installed, what's happening is there's a resistor that it goes to this middle pin, and it goes off to whatever it's hooked up to. And this middle pin, you could see, is actually hooked up to the positive rail of this card. So that's pulled up all the time to 5 volts when it's not installed. But when you install on this bottom one, it's actually connecting to ground. And whatever this signal is, this one right here, we'll have to figure out where that goes, is now grounded and possibly turns off whatever that signal is. So let's see if we can figure out where this via is going. Is it this one right here? Yeah, I think it's this right here. Let's just double check. Would be on this side of the resistor. Yes, it is. And it goes down underneath the EEPROM. Oh, I can remove the EEPROM because we can see through that socket. All right, so it goes from the resistor to there. And is it that? No. It goes to this pin on the EEPROM. Okay. It's a little hard to see, but I think it's, yeah, I think it's basically that trace goes under there and it's right here. So it goes to there. Does that go anywhere else, that pin? No, it's not hooked up to anything. And that is the programming pin, which needs to be pulled high all the time for normal operation, which is definitely what's happening with that pull-up resistor. So putting that jumper on there, I have a feeling will disable the ROM entirely. That's an odd way to do it because you would think you could just do the disable with the chip select enable coming from the PAL. But let's give that a try. Let's place a jumper on there, and I fully expect the card to become inaccessible. And what we can do is we can do this with the card installed in the running system. That way we can see if this chip goes away as soon as I set that jumper. And we can do that from debug. And I don't think that should crash the system while this is happening. Okay, so I grabbed some jumpers here so we can pop one onto there once the system boots up. I keep getting jumpers that are the wrong size. All right, here we go. Let's put the jumper in place. Wait, what? What happened there? I typed the first one wrong up above. Now we're seeing an NCR Corporation ROM? Where's that coming from? If I take the jumper off, there's the DTC ROM? Wait a second, this doesn't make sense. And the two positions on the top of this jumper towards the top edge of the card, that shouldn't do anything at all. Wait. What the? Wait. No, I am confused. I thought that wasn't what was going to happen. So if I put that jumper in either position, we get this NCR Corporation ROM. I wonder if this ROM image we're seeing is actually coming from this other card. No, that's an XT IDE card. What is this ROM that we're seeing here? Obviously the one we're seeing there is the normal DTK one, but what is this other thing? PC0? You know what, we should just dump it, I guess, with ROM Dumper. I have no idea if the computer's even gonna work right now though. No, it's crashing because of course this ROM is used for the drive activity right now and the ROM is gone. So I gotta reboot the system and we're gonna see what this does. Is this another image that's on there? I mean, oh, you know what, everyone? I didn't realize that this is a 256 ROM and the pinout that I looked up where it was like that programming pin, that was for a 128. Yes, that line that goes to, this jumper, is address line 14. Let's check the voltage on that line right now. We'll use this multimeter. I just want to see what changing that jumper has the effect of doing. Okay, so we are logic low. If we take the jumper off, I'm assuming we're going to be at logic high. Yeah, 4.8 volts. So it's being pulled up just like I thought it would. The other thing is I didn't think that either position of that jumper would have that effect. I thought it was only the down position, but it seems like it's the up and down position that has that effect. Let's just double check that again. Yeah, that does also pull it down to ground. So having it off allows it to float up to 5 volts, and then that ROM works as expected. Okay, so whatever ROM that is, it doesn't seem to do anything, you know, at boot there. So what I'm going to do is I'm going to install this jumper. Let's see here. Yeah, I'm going to install this jumper in the down position. What we need to do is we need to remap this into a different location so then I can boot the XT IDE so we can actually boot the system so we can dump this other half of the ROM image that's on there. Okay, so according to documentation, if I move this jumper, number 5, over to the other position, this card should become D800. So it will not conflict with my XT IDE ROM. Let's pop this in here so that the system should now boot properly. You know what I need to do is go into the BIOS though, because we got to take out that hard drive type that's in there. Okay, there we go, I took it out. The only thing I'm thinking as well right now, the problem might be is that the other half of the ROM that's in there is supposed to be a full, I bet you it didn't work because it's supposed to be a full 16K. And right now the SRAM is mapped into the 2K on this card, right? Because we know the top of the ROM is not there. It is actually the SRAM chip. So it could be that's why that is not working. What's going on? It did not recognize the XT IDE ROM that's in here. I think these little cards don't make the best contact in these slots because it's not the good coding type, not the gold type like this. Did the computer just crash, really? Oh, retro computing, it's just so full of adventure. How things don't work half the time. I just need to get this computer to boot once. Actually, you know what? Why am I even using this card? Why don't I just enable the ROM on this original card? Because it's also existing at C800. So I gotta undisable that ROM. Give me the XT IDE, please. There we go. Of course, I don't have this plugged in, but at least I can get the system to boot. Excellent. Okay, so we'll turn this off and I'll plug this riser back in so we can fiddle with the jumpers while the system is running again, because I really want to dump that ROM. I mean, I suppose I could just take it out and put it in my EEPROM reader and that would work too. I think what I need to do as well is try to figure out with these jumpers if maybe there's one of these that disables the SRAM chip. We could do that with this thing running in debug, just fool around with these jumpers see what's going on, once the system boots, of course. I disabled high mem sys and EMM386, so this doesn't crash anymore. So now let's take a look at there. That is, oh yeah, that's right. This card now should exist at D800. There it is. There's that NCR Corp, Ballard Synergy ROM Sim, whatever. Version 3 PCI SCSI BIOS? What? What is this? What? Why is this on this chip? Like, did DTC like reuse this chip and just not erase it? Well, they have to have erased it. What the heck? That is nonsensical. Let's see if the SRAM is still there. So I'm just doing the calculation. So it should be DB80:0. That's the SRAM. And it's uninitialized, which is why I think it looks like that. And we can tell this by filling that RAM. So we'll do AB10. And there it is. So that SRAM is definitely there and working. So I have a feeling this PCI SCSI BIOS that's on here for some mysterious reason. I think what's going on is that the top of it's chopped off, like it's probably a 16K ROM, and we need to figure out what jumpers on here will disable the SRAM so then we can see the entire 16K of the ROM. DB80:0. So I can hit F3 to just keep issuing that. Let me pop some of these jumpers off. I'm going to not touch the ones that change the mapping. That's 5 and 6. And I'm not going to touch WS1 since I know that WS1 is obviously the one that controls, you know, which half of the ROM we're looking at. So I'm going to try to use this little pick here and get one of these jumpers off. So I took off 4. And we hit F3, and the SRAM is still there. I suppose what I should do is move it to the other position while the system is running. Oh, I think that did it. I think that disabled the SRAM. So theoretically, what we're looking at here is now what's on the ROM chip. And you know how I can test that is by moving this jumper or taking this jumper off, jumper 1, which goes back to the original ROM. And what we just see right there should change. Here we go. Yeah, that's it. So that's the top of the first half of the ROM, and I put the jumper on, and now we're looking at that, you know, SCSI BIOS or whatever that's on there. So theoretically, if we look through this at the very end, well, actually, I don't know for sure what we're looking at, but it makes sense that this is the SCSI BIOS, right? I think it does. If we go all the way to the top, which should be, oh yeah, look, it's talking about that Ballard stuff again. The very top should have like a bunch of zeros like we're seeing there, and then it should have that checksum byte, and that will be at 7FF. So DB80:07FF should have that checksum byte. And that will tell us that this is a 16K BIOS. We're almost there. Oh no, that's it right there. And there was no checksum byte. Wait, why is it looping around? That is odd to me, because if we look at D800:0, that's the same thing. Okay, I'm confused. DB80:0700. So that's the very top, which would be the SRAM normally. But if I take this jumper off that goes back to the original ROM, should be all zeros as well. So that's the same. And then it loops around. I think this is an addressing thing I just don't fully understand with x86 systems. Intel addressing modes are weird, you know, with this whole colon thing, and it's using pages, 64K pages on the entire memory space, and that's what's going on with this whole colon thing, and it's super confusing. It can be if you're not used to it. I'm sure someone in the comments will probably post some, you know, help that will, you know, make it really easy to understand. Either way, it doesn't look like we necessarily have a checksum for this BIOS, this PCI BIOS that's in here. it definitely seems like that it's, what is it? Jumper 4 is the one that disables the SRAM though. Because I'm going to update my notes here, and I'll send this to RetroWeb so people will know how to use this card better. Right, so as it sits right now, I have the other ROM enabled, the other half of this ROM, and then I also have the SRAM disabled. So I'm curious, I mean, even though we don't see that checksum byte at the top of the 16K, it's possible that this does work. You can manipulate the bytes within the ROM where the checksum byte just needs to be 00 at the end for it to actually work. If we see some kind of SCSI BIOS, if we see a SCSI BIOS, look at it, works. There it is, SCSI BIOS. What the heck is this doing on this chip? This is nonsensical. Obviously the hardware that goes with this PCI SCSI BIOS is not there. So it's trying to talk to it, I guess. But yeah, so as I was saying, you can manipulate the bytes in the ROM image where the last byte, the checksum byte, which would normally be a number, could be 00. It just has to like all sum up to 00, which I guess is what's happening with this ROM. But with the SRAM mapped into the top 2K, that's not working, right? Because the SRAM has some content in it when it initializes, when you just power on the system, that is. I guess this causes the system just to hang. Yeah, it's obviously not happy. So what we can do is I can just re-enable the SRAM and we reboot the system, and that'll cause that BIOS to not have an appropriate checksum anymore while it's totally frozen, the hardware. The BIOS will have an incorrect checksum, so the ROM BIOS on the motherboard won't even try to execute that code because it basically looks for that header at the beginning, which is like a AA55 or 55AA, whichever, can't remember which one it is, and then it looks for that checksum byte. If the checksum byte's not there, or like that first header's not there, it won't actually try to execute it. So right now it should execute XDIDE, which is what's happening there. What we can do is we can boot the system, and then I can re-disable the SRAM. So the SRAM being enabled is what kept it from booting. So I'm going to re-disable the SRAM chip. And now this thing did not freeze. We can run ROM Dumper again, and that will dump this BIOS. So if anyone wants to take a look at it, I'll upload it somewhere. Okay, so we have the DTC ROM. That's the actual 14K of ROM that's in the first half of this. But if we run ROM Dumper now, so we got some new images. So what we have here is we have C000, we know that's the VGA card. And then we have C800, that's the XDIDE card that I'm currently booting off of. And then we have the D800 to BFF, which is a 16K ROM, as you can see just up at the top there, and that is that SimLogic or PCI weird BIOS. So we're going to rename that. Oh, I made a typo there, so we'll just fix that. And now we can do uhex and PCI BIOS.ROM, and there it is. There's our NCR PCI SCSI BIOS. I still don't really get what they did here. Like, why is this even on here on this DTC card? It makes kind of no sense to me at all. But if we go down to the end, yeah, notice the checksum byte, just zeros, but that's because they probably have some filler bytes in here somewhere else to make it all add up to 0 at the end. Ballard SY PCI-R. That says NCR 5371110. I don't know if it's a model number of a machine or something. Copyright 1993. I mean, it's like copyrighted ROM code on here. It's very strange to me. It's very strange. And DTC ROM, is this a DTC ROM? Yeah, copyright DTC. Why? Questions. I got questions. It just makes little sense. Okay, well, what this is telling us right away is we can put a 16K EEPROM on here. If you don't need the SRAM, you just disable it with this W4. But then what do these other two jumpers do? Let's power the system off again and take a closer look at those jumpers, or the traces for those jumpers. So what we can see is we know these middle pins are the ones that actually do stuff, right? That goes to various things on the board. So we know that jumper there is selecting whether you're on the first half or the second half of this. And then we know this goes into this PAL chip. That's for selecting where the memory space is mapped. There's got to be two chip enable or chip select lines that come out of this that go to these two chips to enable them at the appropriate time. It is my assumption that this LS245 is hooked up to the data lines that are on here. So I have a feeling the ROM and the SRAM don't talk directly to the ISA bus. They actually go through this bus transceiver. This needs to be driven as well. There's a direction pin on here along with enable pin. That's probably coming from this chip. And a little bit of probing around tells us that, yep, these are going into the input pins of the PAL chip here. So that's pin 1. This will be pin 2, pin 3, pin 4. So we know that these jumpers here 6, 5, 4, and 3 all go to the PAL, so they all do something at least. And then as for this jumper, the bottom one, which I still have on, don't know what this one does. Let's see if we can see what it's connected to. Okay, so this one here we know is the one that selects the top half or bottom half of the EEPROM. That goes through that pull-up resistor, so it's that via. But this one goes there to the SRAM chip. We're gonna have to look up the pinout. And then the bottom here, this where it normally is connected on the bottom, goes to that. So let's see where that via goes. That goes to that pin. That's the SRAM chip. So that's interesting. When that jumper is installed, it connects that pin to this pin. And the top one, I don't think is connected to anything. Okay, no, actually the top pin is connected to the EEPROM. Let's see if it's connected to anything on the SRAM here. I figured it's an address line we're looking at here. That makes the most sense. And it's because this card supports larger SRAMs than what's actually in here. Yeah, it seems the top pin actually makes its way to that. We're gonna have to look up what that is. And remember, it's the bottom that is connected these two pins together. Okay, so to reiterate, that top pin is connected to there on the EEPROM. The middle pin on the jumper block there, this is for jumper 2, that goes to that pin. And then the bottom pin goes to right here. And obviously that's not populated because we don't have the larger chip in place. And it looks like the pin on the EEPROM is address line 11. That's this one. And it appears that this pin on the 2K SRAM, that's the write enable line. So that pin there, when the jumper's in the proper configuration, is connected to this pin that's not populated because there's the chip is the smaller one. But my assumption is this must go to the ISA connector for write enable. So if we put a larger chip in here, I think what this jumper allows us to do is reconfigure this so that, well, write enables are already here, but then this becomes address line 11. Let's take a look at the footprint of the larger SRAM chip. Here it is. My assumption is, yes, look, write enable is up there. So that's this position, that's write enable. So this is what, 28, 7, 6, 5, 4, 3. This pin right there, 23, is address line 11. Okay, so yeah, setting this jumper into the upper position, so on pins 2 and 3, that hooks up address line 11 to the EEPROM, to the SRAM, and then, well, otherwise when you're using a 2K, you need this to be write enable, so that's the lower position. That enables this to be written to. So definitely this second jumper has to do with whether you have an 8KE SRAM in here or a 2K. Now the question is that the PAL that's obviously selecting this, does it even know or have a capability of operating with an 8K EEPROM or 8K SRAM? It must, and that could be the extra jumper here that we haven't figured out yet. We know this jumper and that jumper have to do with where it's mapped in memory. We know this one here disables the SRAM entirely, and what we don't know about is this jumper, jumper 3. So my assumption is that one, which we know goes into the PAL, it must change it where this ROM becomes 8K instead of 14K or 16K, depending on whether or not this is turned on, and then this is turned on for the 8K. We can test this actually pretty easily. Jumpers are reinstalled, so we can get this thing to boot up again. And I have it set so the SRAM is enabled right now. That way, it's not going to try to load that NCR Bios, which we know doesn't work. So we're seeing the NCR Bios. That's as expected. And we should have the SRAM up at the top. So DB80, I think is, how do I get to it? Yep, there's the SRAM. So this is what we figured out so far. So we know that 5 and 6, that has to do with the memory location of where this stuff is mapped into. We understand that. We know that jumper 1 has to do with changing whether you're in the first half or second half of this larger EEPROM. We know that jumper 4, if I take this off, will disable the SRAM. If I put it in the 2-3 position, that is. So that goes into the PAL chip itself. And now it just allows the EEPROM itself to be 16 kilobytes. So there we go. Now we're looking at the EEPROM. So I'll set that back to 1-2. So we now have the SRAM again. And we know that it's jumper 2, that when I change that to the other position, that is designed to reconfigure the pinout of the SRAM chip to allow for 8K. Well, since I don't have an 8K in here, and I need to put a socket in there to test this for sure, well, I'm positive that's how that works. The thing is, what we haven't addressed is jumper 3, and that is the memory map where there's a split between the SRAM and the EEPROM. It is my hypothesis that if I change this over, then basically the SRAM, which is only 2K in size right now, will take up the entire top 8K of the memory space of, where this card is being allocated, which right now is D800. So changing this over should not have any effect when I refresh this. We should still see the SRAM. Oh, we're not. Curious, very curious. So that was jumper 3, and we're definitely looking at what's on the EEPROM again. So where is the SRAM? Did it like remap it into a different place? Okay, well no, it's not there. I mean, this is all the ROM. I didn't expect that to happen. I would have expected the EEPROM to exist like at the 8K boundary, for instance. So it would be 8K of EEPROM and then 8K of SRAM. So we're going to look first at 4000 hex of this memory space, which should be 8K. It's just going to scroll real quick. What we're looking at here is the EEPROM. Remember when we see the SRAM, we see like a bunch of FFs and 00s, so it's sort of obvious. Let's see. This is definitely all EEPROM. Yeah, all EEPROM. Oh, you know what? I just realized that 4000 hex is 16K. So we looked at all of the address space, and that SRAM wasn't anywhere to be seen. And that was with jumper 3. And I thought it was jumper 4 that disables. Maybe they have to work in combination with each other, because these both go into that PAL chip. Maybe I can put them both on 2.3, and let's see what that does. D800:0 and 4000. So this is again the ROM BIOS, and I'm fully expecting to see I'm making sure my pause key works. It does. Fully expecting to see this SRAM in here somewhere, but we're not. Huh. Oh, wait a second, everyone. It looks like it's looping. So here's what I mean. If we look at DC100, there's the BIOS again. So it's looped. So the memory space that this card is using is more than 16K now. So let's fiddle with these jumpers. I want to see which one of these caused this loop to happen. So I'm putting back jumper 3. No, it's still looping. Okay, I put jumper 3 back onto 2.3. I'm going to change jumper 4 from 2.3 back to 1.2. I want to see if this looping is going away. And this looping is happening because the EEPROM that's in here is only 16K. So it's just addressing it, twice. Okay, there we go. The loop is gone. So I think jumper 4 it doesn't disable the SRAM. I think it expands the address space potentially to 32K instead of 16K. We'll have to see where the upper boundary is. I originally thought that it was disabling the SRAM entirely, but I have a feeling it was moving the SRAM up into a higher position, something like that. Or maybe it does disable it. Maybe it does both. I don't know. So I put the jumpers back to the stock configuration. So it's not looping. Okay, so let's move jumper 4 back into the 2.3 position, which my assumption is it turns it from a 16K card into a 32K card. So I'm assuming now it's going to loop. There's the loop. My assumption is the SRAM is mapped somewhere into that upper chunk. So here's what I'm talking about. So let's take a look first at the first 16K of the card. So we're going to look at 4000. Well, 3FFF is actually truly what it is. So what we're looking at here is entirely just the 16K from the EEPROM. And remember, we can tell the SRAM because it's 000FFF000, right? So it's an obvious pattern that will appear. It's none of that. Okay, there we go. That's the end of the ROM. Now we do that same command again. We're going to be looking at the loop of the ROM. So this is the upper 16K of the memory space that this card is using. I mean, it could be using 32K, it could be using 64 for all I know. I don't know. So let's look for the SRAM in this upper chunk. There it is, right there. So it's at 3800, which my assumption is, if we put that jumper back to 1.2, so notice we're at DC00 and it's at 3800, that's the offset, where we start to see it. I bet you if we switch it back to 1.2, we're going to see the SRAM at 3800, but the offset will be at D800. So this is all SRAM here. Okay, so if we do D800 and we look at 3800, this is going to be the ROM chip right now. But if I swap this jumper back to the 1.2 position, then it's going to be the SRAM chip. I'm positive of this. Yeah, SRAM chip. And we know that the card is now only using 16K, so that's it. It's just, that's the SRAM chip. Okay, I'm going to put jumper 4 back on 3.2 because I want to put this card back into 32K mode or whatever. I want to see, does this card take up more than 32K of address space right now? With this jumper in the 2.3 position, our 2K SRAM is mapped right here. There it is. Now, if this card goes beyond 32K, then what we're going to be looking at is E000, and that is just FF. Okay, that pretty much confirms that that jumper 4, configures the card into a 32K mode or a 16K mode. And when it's in 32K mode, the 2K SRAM ends up being at the top of the address space. And when it's in 16K mode, it's also at the top of the address space. So now my question is this jumper 3 simply disabling the SRAM chip? Because I thought jumper 4 disabled it, but it doesn't disable it, just moved it up higher. Does jumper 3 disable it, or does it enable 8K mode? And when we enable 8K mode and we have a 2K SRAM, we should just see 4 copies of it. So right now, I have it on 2.3 for jumper 4, and I have it on 2.3 for jumper 3. So that tells us that right now, we're going to see a mirror of the 16K EEPROM right here. That's as expected. And if we go to offset 3800, we're going to see the SRAM. But we don't. So it truly seems like jumper 3 totally disables the SRAM entirely. So there's the SRAM enabled. I have it on 1.2, jumper 3. And if I move it to the other one, it seems like it's just gone. Yep. It is gone. I mean, I'm just checking to see if it like moved it outside of the address space, but I don't think so, because I know that's the top of the address space. So let's take a look at the entire address space here in the second copy of the EEPROM. So the SRAM is not there in the bottom section, and let's check the top section, or sorry, other way around. It wasn't there in the top section, that DC00. Let's check D800. I don't think it's here either. How odd. No, it's not there. I'm going to put jumper 3 back to the position that enables the SRAM. So it's not going to be here, it's going to be up in the top section. And what I'm going to do is I'm going to change jumper 2, which we know is the one that configures how big the SRAM is. Maybe one of those signals goes to the PAL chip as well. Like it's able to figure out that, that change has happened. Okay, so we did not see it there. That means the SRAM is available right now, but it's up in the top section. In fact, I could just go right to it. There it is. So I'm going to change this jumper 2. Now, since I have the wrong SRAM in there, it's not going to be able to write to it. And address 11 is just floating. So this may or may not even work properly. I'm just wondering if like the jumper 2 actually has a signal that goes down to the PAL chip to tell the PAL, hey, by the way, I am also now configured. I cannot get this jumper off. My little pick is not behaving. Sorry, I keep trying to talk and make this recording at the same time, and I cannot get this pick to behave. There we go. What I'm trying to say is, with jumper 2 set for 8K SRAM, it may not work because we have lines that are floating on here. I mean, we could test this by, okay, so we still see it there. So that's good. But now I'm wondering if there's a signal that goes from jumper 2 down to the PAL to tell it, hey, go into 8K mode. So we can do our thing again where we look at the DC space, because we're in 32-bit mode here, and we're going to look at the entire space. And let's look to see if we start seeing more copies of the SRAM. My hunch is instead of starting up at the top 2K, it should start at the top 8K. No. Nope. No difference. There's the SRAM at 3800. And this is just 2K worth of SRAM. Okay, well, it appears that there doesn't appear to be a way to get this PAL PAL chip to actually address all 8K of SRAM. So if you have one of these cards, the only way you can actually, well, use it is with a 2K SRAM. And I don't know why there's extra pads like to support the footprint of an 8K, but they're there, but it doesn't seem like the decoding on the PAL chip is set up to enable that. Now you could totally make your own PAL chip to fix this and turn this into an 8K, well, 16K EEPROM plus a mirror of it, and then you have an 8K SRAM up at the top of the space. But it seems like right now that's not happening. All we ever get is 2K up at the top of whichever address space we're configured for. So if we're in 16K mode, you get 14K of ROM, 2K of SRAM, and if you're in 32K mode, we're going to get, well, 30K of ROM and then 2K of SRAM, and you can disable the SRAM chip and just get all ROM. I suppose the only reason why you'd want to configure the jumpers for 32K mode is if you want to address all 16K of the ROM and then have 2K of SRAM as well. And it seems odd to me that they just didn't program in a way for this to know you have an 8K SRAM in here, so you could have all 8K available on the top chunk, and then you could have 16K of ROM in the bottom. Okay, here's what I've come up with. So we'll start at the jumpers down here. So first off, W1, we determined that selects between which half of the 27256. The jumper should not be installed if you have a 27C128 or you want to use the first half of the 27C256. Otherwise, you set it to 1.2 and that'll give you the other half of your EEPROM. Maybe you have some mystery data in there if you have a card like this, like we did. Then W2 selects whether the SRAM is a 2K or an 8K, configured basically. It reconfigures the actual pins that are on here. It doesn't seem to change anything with the PAL, the way it's mapped, but it just reconfigures the actual pinout to allow you to physically install an 8K EEPROM or SRAM. It seems like it will always just use it as a 2K, but at least you can install that in there. So it's flexible that way. W3 just enables or disables the SRAM. 1.2 is the normal configuration if you want to enable it. But if you have one of these that doesn't have the SRAM, you should set that to 2 and 3. That way you have the entire ROM available to you. Then you have W4, which configures the address space, which is described up above. 1.2 is a 16K address space total. So if you have the SRAM, remember you get 14K, well, it's up here, right? You get 14K of ROM and 2K of SRAM. And if you're in 32K mode, just need to kind of fix this, you get the ROM once, all 16K, then you get another copy of it, but only 14K. And then at the top of the second copy, you have your SRAM. And then the last jumper is configure how it's mapping into the memory space. Now, the funny thing is, if you're in the 32K space, then your C800 is going to take up the other half there. Basically, yeah, 32K takes up 2 of these. So I suppose the question is, W5, maybe I need to do a little bit of investigation just real quick with the W5 jumper, because maybe this is not exactly right with this memory mapping stuff. And I should set it to 32K here, and then I should set it to 8K, or no, I should set it to 32K, and then maybe the W5 jumper is actually the SRAM jumper. Interesting thought. Let me just quickly experiment with that. So I currently set the jumpers to 16K mode, but I also set 5 and 6 to 1.2. So it should map the 16K to DC00. I'm just going to verify that's actually the case. And I have the SRAM enabled. And I have it set to use that SCSI BIOS, so it shouldn't even show up here. Okay, here we go. Let's take a look at what we see. So definitely the BIOS is there at DC. And let's see where the SRAM is. Should be at 3800. Once we get there. Almost there. 3800. There it is. Okay, SRAM is in the right spot. The question is this definitely not at D00 right now? Let's just check. Okay, it's definitely not there. So it's only at DC right now, and it's in 16K mode. So DC000. Okay, well now my question is, if I change W4 and I move this to the 2-3 position, this is the jumper that controls whether it's in 16K or 32K mode. And I want to know what that does exactly while it's set. The memory map is starting at DC. So let's see if it's, okay, so it's definitely still not at D800. well, it's not at DC anymore either. So this is like an invalid mode, I guess. So it definitely was at DC a moment ago. Let's switch it back to 16K mode. There it is. Okay, so it looks like to me you can only use these modes, DC00 to DF and CC00 to CF, if you're in 16K mode only. Meanwhile, DC or D800 and C800 works on either mode. And then it just marked all of these for which are the default. So W1 not installed, default. W2, 1 and 2 is the default. W3, 1 and 2, that's the default SRAM enabled, 14K of ROM space. W4, 1 and 2 enabled or default, that's basically 16K mode. And then, well, I don't know which is the default for the ROM space. It says from RetroWeb that it was 2.3 and 2.3 for 6 and 7. And the memory maps, I think that is correct. Yeah, I think everything here is all correct now. So I suppose the one oddity with this card, there's two oddities actually. One oddity is that this thing had like some copyrighted BIOS in the other half that's not even used, so that's odd. And then the other annoyance is this has a 32K mode that if you disable the SRAM, theoretically should work, but it just seems to mirror the ROM twice, and you can't have access to the entire 27C256 EEPROM, which is 32K. It's weird. You know, I finished recording this video and I just realized, like, I don't know what I was talking about with a 256K EEPROM. A 256, this chip right in here is a 32K chip. So theoretically, there should be a jumper configuration on here that would allow us to see the entire EEPROM all at once. And I just had a thought that it's probably the W1 jumper. Remember, when the jumpers were moved, you see just the lower half of this EEPROM. And when it's on jumpers 1 and 2, you see the upper half. But what about if we have it on jumpers 2 and 3? Maybe we could see the entire contents of the ROM while it's in 32K mode. And it's not right now, so I need to switch it into 32K mode. So that is W4 jumper. And I might as well disable the SRAM, which is W3, put that on 2 and 3. Okay, so we're D800, and if we look at 3FFF length, we should see the first one, which is the DTC BIOS. Oh, I think what's happening now is I have it set to one of the address locations that is not compatible. Yeah, I do. So W6 needs to be on 2 and 3, because that's one of the 32K compatible addressing modes. Because remember, 2 of them can't work with 32K, and 2 of them can. So now we should see the ROM. Oops, I missed which one it was there. Okay, so we hit pause. Okay, so we're seeing the NCR ROM, even though I have the jumper set to the middle position. What if we take the jumper off? And we do this again. Okay, so now we're looking at the DTC ROM. Now the question is, if we look at DC100 right now, are we going to see the NCR ROM? No. So we're getting a mirror copy of the DTC ROM right now. So let's try both settings on W1 here. Okay, so now we're getting the NCR ROM. That's on 1 and 2. If I move it to 2 and 3, oh, there we go. There we go. If I have it set for 2 and 3, now we're seeing the DTC ROM at DC800. But what about D800? We're getting it all. So that's it. So W1 on 2 and 3 is the configuration for 32K EEPROM. So you see all of this EEPROM. And if you set it to 1 and 2, we're only going to see half of it. And when you remove it, you see the other half. And you see 2 copies of it. And what we figured out is now that we're seeing the entire ROM, it looks like the NCR ROM is first in the ROM, the physical ROM chip, and then the DTC ROM is second. So I need to update my documentation. Okay, so here are my changes. So W1, not installed, second half of 27C256. That's the way this card was when I first tried it. When 1 and 2, when you're on W1, 1 and 2, you're looking at the first half of this EEPROM, which happens to be this weird NCR BIOS. And then 27C128, if you have one of those, it's probably the configuration you need to be on. And when W1 is on pins 2 and 3, then you're going to see the whole chip if you have the card in 32K mode, which is W423. Obviously, if you're on one of the other two modes, 1 and 2, or not installed, then you're going to see duplicates. You just see that whole section twice if you're in 32K mode. And then, of course, the SRAM can be mapped in or out. So that's how it works if you want to see the 32K ROM. So there we go. That was a little bit of exploration and just sort of fun kind of decoding how this card works. Do I need this card to work? No, not really. I have plenty of cards that do the same thing, like these. I don't need this, but it's just sort of fun to uncover how this actually works. And I'll upload all the info that I figured out here in that notepad document to RetroWeb. So if anyone does have one of these and you're using it for its intended purpose, well, with these jumpers, you'll know how to use it. So if you want to use a full 16K EEPROM and you don't need the SRAM, well, make sure you disable it in the jumper, or if you want to mod this for 32K, you can do that as well. That's the DTC 1181 and just sort of a little fun casual video exploring how this card works. And I'll upload a copy of both ROM that are on here, like the wrong one and the right one, that weird NCR one and the other one. So if you want to take a look at what those are, maybe that NCR one is somehow awesome and usable, then, that's great. Otherwise, it's just sort of a weird oddity. And I'll be curious if you have one of these, if you have some other strange ROM that's in the other half of this chip. Pretty weird, huh? As for Jim Leonard's utility, I need to figure out how I can link to that because people often ask about it and I'm not sure. I found that on the internet a long time ago, and then Jim made a new version with some bug fixes. The one I have that I ran here is from 2023. So I will try to get a link to that. If not, you should be able to Google, Jim Leonard and ROM Dumper and be able to find his stuff. Anyways, that's it. Hope you enjoyed this video. If you did, thumbs up. If you didn't, you know what to do. Huge thanks to my patrons and supporters. Their names go on the side of the screen and make it possible to do this full time. And all the other YouTube junk, comment down below, blah, 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 blah. And stay healthy, stay safe. I'll see you next time. Bye.